been a while since I've done a project video, but I was working with my mini mill and using this little speeder handle I made a year or two ago. And I made this sort of as a proof of concept. I was frustrated by the big handle that comes with the vise because it's great if you want to clamp down on something tightly, but it's not good when you want to spin it quickly to open or close the vise jaws by more than, say, a ½ inch or so. So I made this little speeder handle, and it works great, but the fundamental part of it here, this central part, was really something I just knocked off very quickly as a proof of concept. I just wanted to see if it would work at all, and then I added a little back plate and a roller handle to it, and it was good enough, and good enough that it worked for what I needed, and so I never improved it. But I've always been a little embarrassed to show it on the videos because hopefully it isn't representative of my normal quality of workmanship. So I thought I would take some time and show you how to make one of these and clean this one up. And I'd like to have two of them anyway, because I use it both on the mini mill and over on the larger SX4 mill. So let's go ahead and get into that. Well, the handle is pretty simple. It really has just three main parts. This central part, I don't know what to call it, and then this round plate, which you can see is a very simple lathe project, and maybe drilling and countersinking these two holes on the mill, and then this roller handle, which is a simple lathe project, and then it uses just a standard hardware socket head cap screw, and that's pretty much it. So not too hard to make. The only tricky part at all really is this main part. So we'll look at that because we have to cut a hex in there, which if you've never done it can be a little bit of a problem. And I didn't do a very good job on this one, so hopefully I'll do a better job. The vise I use most often on my mini mill is this 3-inch machinist vise or milling vise. It's from Little Machine Shop, and it is part number 1699, and it has a 3-inch capacity. The jaws will open up for holding a 3-inch piece, or 77 millimeters. If you're making small adjustments to the jaw opening, you can use this stock handle that comes with it, and you can use it like this to speed up the process a little bit. But when you try to open it up wider, it becomes kind of unwieldy, and this handle can easily fall off and hit you on the foot or something. So it's really not very convenient. And I tend to use this mini mill quite a lot, so this is an operation that gets done frequently. So after years and years of just putting up with it, I decided to do something about it and make this little specialized speeder. If you look in the machinist tool catalogs, you can see ones similar to this that are kind of a stock item for larger vices. But anyway, let's go ahead and start on it. This is the piece that we want to focus on because these other pieces are okay. They're well enough made that I want to reuse them. Now, unfortunately, when it comes to dimensions, this is basically made to somewhat arbitrary dimensions. I probably just found a piece of stock in the scrap bin that would about fit to what I wanted, and cut and filed it and probably milled it. I think I milled it and then filed it and maybe sanded it just to get it to the approximate shape that I wanted. But the dimensions of this were pretty much arbitrary. Then I made these two pieces to fit, so the dimensions of this round disc were probably made to fit this, and therefore, probably won't come out to any even units. And the handle, the length of the handle was chosen to fit the bolt, and to be large enough diameter so the bolt would fit down inside. So the dimensions are going to be somewhat arbitrary, but I'm going to try to normalize them a little bit, which is to say, if I can make them into even numbered units, I'll try to do that. So I guess what I'm going to have to do is go with the dimension of this little guy here and fit my new piece to that. So we'll start with that dimension and work around it and see where we end up. The length of this arm here was pretty much just an eyeball decision. I decided that it needs to be long enough to give me a little bit of leverage to tighten the vise. short enough so that it doesn't swing and bump into things, and but also short enough so that you can rotate it rapidly, which is the whole point. First thing I like to do is make some rough sketches, and this just gives me a general idea of what I need to do and the essential dimensions for getting the job done. Since this is going to be on the mini mill and everything is metric on the mill and the vise, I decided to use metric dimensions rather than inches. But of course this socket head cap screw here is a standard SAE bolt. Well, the next step is to find what I call some candidate stock. I first look in an appropriate bin here to see if I can find some scrap material that's approximately the size and shape that I need, and start with that. In this case, I didn't find too many pieces that were close to what I wanted to make. It has to have a certain thickness, and I wanted to have a little more thickness on it than the original. So this piece is a little thinner than I would like. It would do the job, but there'd be more leftover scrap. And this piece seems like a good choice. It can be cut down with a little waste, and it is a little bit thicker, which I want. The reason I want it thicker is that this existing handle, you can see if I slide it over the end of the screw here on the vise, it sticks out a little bit. So I've got some extra room here that I could take advantage of with a little bit thicker piece, and that's what I want to do. So this will be our candidate piece. You can see it's a pretty good fit, and we'll do some layout work and then start cutting that down to the size and shape we need. But interesting bit of shop lore, you can see these multicolored backside on here. One of my granddaughters used to hang out frequently in the shop, and she liked to find aluminum, shiny aluminum, and embellish it with colored markers. So I've got lots of little scraps like that with colors on them. But I worked out the new dimensions that I want to use, and I used this back plate here as a starting reference because I want to use this piece, and so it happens to be 31.60, so that will be the diameter of the round part on our new piece here. And as far as the length goes, the length of this one seemed pretty good, which was 68 overall length, so I decided to stick with that. Or actually, it was actually 67.84 on this one, and I decided just to normalize that to 68.0. And so if you subtract the diameter here from that, you end up with 36.4 for this part. The stock is a little bit over 17 millimeters thick, and I'm going to do a little surface finishing on it on the mill, so we'll bring that down to 17.0. And then the hole for the roller handle is approximately 8 millimeters from the end, so from the end to the center. And so we'll go with 8.0 for that. So those are the basic dimensions we need to get started. So next I want to clean up this piece of scrap and get some clean edges on it and some clean faces. And it was interesting, just in looking at this, I noticed that this is a really old piece from back when I was first learning to use the mini lathe and did not have a mini mill or any mill. And if you look carefully, you can see that the ends of this, and actually all the faces on it, were turned on the lathe using a 4-jaw chuck, and they have the characteristic sort of bullseye appearance from those operations. So I've come a long way since then. Hopefully I can do a better job now than I did then 20 years ago. To do the cleanup work, I'm going to use these carbide insert tools, and I got these from Little Machine Shop a year or two ago, actually probably 4 or 5 years ago now, I guess. But they do a real nice job of giving you a clean surface, and of course they do a nice wide cut in a single path. So we'll use this smaller 1-inch diameter tool to do the edges, and then we'll use this larger 2-inch diameter tool for the two faces. So there's our first edge. I'm going to take it over to the belt disc sander on the other side of the shop and just clean up these edges here so I don't have any burrs that might throw it out of alignment. that looks a lot better. I still have a little bit of roughness on the edge here. Maybe that one or both of those carbide inserts is chipped. Might take a look at that under the microscope and see. For the last two edges, I decided just to mount the workpiece horizontally in the vise, and I'll just use a conventional end mill here and mill those off square with the rest of it. Now set the depth a little bit deeper. We're doing a conventional milling pass where we're cutting into the direction of travel here. And then when we get to the end, we'll feed it in just a little bit more, and we'll do a climb milling pass, which will give us a smoother finish. So there's our end after it's been milled, and we'll just flip the workpiece over and repeat that for the opposite end. Okay, well, it's about 7:15 p.m. the same day, and it's gotten a lot colder outside. It's down to about 33, and it's going to go down to, I think, 28 or something tonight here near Richmond, Virginia. So I've put on a long sleeve shirt, and I'm ready for the Arctic blast. But just so you won't think I'm a wimp, I lived in northern Vermont, or central Vermont, well, actually on the Vermont-New Hampshire border back in the 70s and the 80s. And it routinely got down to 10 or 15 below zero there. So I'm no stranger to cold temperatures. But now that I'm older and retired, I kind of like the mild winters down here near Richmond. Well, now that we have our rough stock pretty well squared up and close enough to get the job done, let's go ahead and put some layout dye on here, and we'll mark out our part, remove some of the excess metal, and get on with it. Now, of course, there's various ways you can tackle this. If you have a dimension drawing, as we've already put together, and you have DROs on your mill, you don't really need to put any layout markings on here at all. You could just work from the DROs and the dimensions and arrive at the desired result. But even though I can do that, I like to use the layout die for two reasons. One is that it acts as a safety check in case I make a stupid mistake. I'm more likely to see it if I have the markings here on the part than if I'm just going by dimensions on the DRO. For example, if I accidentally shifted or zeroed out the DRO without realizing it, it could throw everything off and ruin the part. By having the guidelines on here, if that were to happen, I have sort of a safety or double check against the DRO readings that hopefully will keep me out of trouble before things get too far out of whack. So that's a philosophy on that. But another reason is that for a tutorial like this, where I'm trying to teach people with less experience how to use these tools and techniques, this illustrates another way of doing things and the visualization that you can get from using layout die. So I've been using this Dichem brand, or some people pronounce it Dichem, but I've always pronounced it Dichem since the 70s when I first started using it. And so put a little bit of that on there. If you aren't familiar with it, it's a kind of a thin, dark colored dye almost. It's almost like a lacquer, I guess you could say, rather than a dye. But you spread it on your workpiece and it dries fairly rapidly. And then you can mark it with a scriber to give you guidelines for doing your work. So that'll take about 30 seconds to a minute or so to dry. So that fan just helps to evaporate the solvent in there and dry it out a little quicker so we can get on. You got a nice red color on that, or blue if you prefer. Well, the next thing I want to do is measure the height of this block from here to there. And then we'll put a center line on it, and then we'll reference off of that center line to mark out the features for the piece that we're going to be making. So there's our center line, And of course that's the purpose of the layout die, is to make it easy to see these lines. And I like to, on a center line like this, I like to flip the work over and make sure it lines up to be sure that in fact it is on center. So to center our workpiece end to end, I measured the overall length of the block, and that came out to 74.93. And you can see from the diagram here that the overall length of the finished piece is 68.0. So if we subtract 68 from 74.93, gives us 6.93, which is the total of the extra on the two ends. And then to split that out so that's even between them, we divide by 2, and we get 3.47 millimeters on either end. So we'll go ahead and scribe two lines, 3.47 millimeters from each end. Now with those two lines scribed here, you can see if I fit our workpiece between those, it is approximately centered. Now keep in mind that this workpiece is not exactly the same length as the length that I chose for the new one, so it may not line up between these two lines exactly. So what's next? Well, these areas here are going to be scrap material that we're going to mill away, so I'm just going to scribe some hatch marks here so we'll know that that's going to be waste material. And that will help us keep on track here as we're cutting away things. And then we're going to have a circular region down here, but we'll leave that for now. So I think as a first step we'll cut away or mill away this. Now we could speed up the process a little bit, and maybe I will, by cutting these first on the bandsaw and then just finishing them on the mill. Or we could, since it's not a real big chunk of metal, we could just mill it away. But I think I'll give it a try on the bandsaw first and see how that goes. Well, I'm not sure why, but I didn't have very good success on this Delta bandsaw. It's a combined metal and wood cutting bandsaw. I have the feed rate for the blade pretty high because I'm cutting aluminum, and that may be the problem, but I didn't want to spend time trying to troubleshoot that right now. So I moved the project over to the Harbor Freight horizontal vertical bandsaw, and I'm using a custom-made extra large table that is far more effective than the little scrap of metal that comes with it. It's kind of slow going, but it got the job done. Unfortunately, there was a lot of swarf in the way here, and I couldn't see my guideline, and as a result I cut in a little closer than I should have. I'm actually inside of the guideline, but again, the dimensions aren't too critical, so we'll just even that out on the milling machine and declare victory, I guess. Alright, well I have the workpiece back over here on the mill now, and I have selected a 3/4 inch diameter carbide end mill. I think it'll do a good job on this. So we'll go ahead and clean up that area. I probably should have just done it this way and been done with it to begin with, but I'm a slow learner. Okay, well that looks pretty good. I'm still above the line there, but I'm going to leave it for now. We may come back towards the end after we clean up the other side and finish these cuts down to a final dimension. I want to clean up some of these burrs with a file here. Well, now we have to clean up the opposite side. Well, it's the next day in the shop after I made that error in cutting with the bandsaw and cutting inside the line. I decided it was time to quit for the day, and I realized that I was actually feeling pretty tired. And of course, when you get tired, you sometimes make decisions that aren't the best. So never a good idea when working with power tools. And additionally, I realized I'd gotten a flu shot the day before, and I think the flu shot was having some effects. So I decided to call it a day and come back. So it's now the next day, Saturday. Alright, it's looking good. I checked it on the surface plate, and it's now symmetrical and the thickness that we want it. And so what I need to do now, I've got this excess here on the bottom and on the top. I'm going to mill those off. I may leave just a little bit of extra there for finishing, but get that closer to the final size. Then we'll go ahead and drill a hole here and work on rounding this base part. I'm taking off about a 1/2 millimeter per pass. And I'm just working up to that scribed line. Well, this end is really too tall relative to the height of the end mill to mill this way. I'm going to flip it around horizontal in the vise and mill it in the other plane. Alright, well, I milled off about 2.5 millimeters. You can still see I've still got about a 1/2 millimeter here before I get to the line. But I'm going to leave that for now, and we'll clean that up at the very end. In fact, it'll probably get cleaned up when we round this piece here. So let's go with it. Well, for our next operation, I want to drill the hole in the center, and then we need to round this exterior part here. And of course we could use a mill and a rotary table, but many of you may not have a rotary table, so we'll use a different technique. If I needed to position this hole as exactly as possible, I would use an edge finder and center it that way, but I don't need that degree of accuracy, so I'm just using this little carbide pointer here to find the center using the scribed lines, so that will be more than accurate enough for what we're doing here. This is about a 12 millimeter hex, so we want to drill a center hole that's no larger than that, or 12 millimeters across the flats. When I get ready to mill out the hex for this shaft, I'll probably drill 11 millimeters or some SAE approximation to that, and then we'll mill it out to the hex shape. I'm going to drill this out to 23/64, which is just the 1/64 less than 3/8, and then I'm going to ream it to 3/8, and I'll show you why in just a minute. So I'm using a short so-called screw machine drill. These are nice where you don't want much drill flex and you don't need a very deep hole, so I use these frequently for situations like this. We'll go ahead and drill that out. Alright, get that swarf off of there. This is pretty thin stuff, so I'm not too worried about getting cut by it. Now I'm going to ream the hole out to 0.376, or just 1/1000th over 3/8. And if you're not familiar with these reamers, you can get what are called over-under reamers, and they come in sets, with common sizes, but they're actually 1/1000th smaller or 1/1000th larger than the nominal size. So for a 3/8, you'd get a 0.374 and a 0.376. They're used when you want to hold just a little bit larger, so you have a shaft that's going to fit through there, or just a little bit smaller if you're going to use a press fit shaft. In this case, I want my shaft to be able to rotate, so I'm using the oversized reamer. Compared with a twist drill, the reamer gives a much more accurate dimensioned hole and much smoother sides than a typical twist drill will give you. I'm just going to very lightly chamfer these holes, both ends of it, to remove any burrs. Well, if I'd been thinking ahead, I would have used a compass to scribe a circle on here before I drilled out that hole. Now, it would be harder to use a compass to do that, but I'll figure out a way to get it done. This is a technique I've used many times over the years for situations like this. I just took a section of 3/8 inch diameter aluminum stock and cut it to length and faced it, put a little dimple in the center. Now I have a reference point for my compass. Well, technically I guess these are dividers, but same idea. I'm a little off the edge there. bring it in a little bit more. Okay, that will just make the next part of this job a little bit easier. Alright, we're set up now to begin turning this rounded part of the workpiece. And you've probably seen this trick before, or maybe not, but many years ago, back in the 70s, when I had my first mill, I couldn't afford a rotary table, and I found this trick somewhere, maybe in an old machinist book, or where maybe I just figured it out. But anyway, it comes in handy a lot of times. You can rotate your work around here and clamp it in the vise, and then incrementally mill across, making many cuts until you get the basic shape you want. And of course, you don't get a nice smooth edge here like you would with a rotary table, but you usually get it close enough that you can then take it over to a disc sander, or maybe just use a hand file and a vise and finish that surface. Now you can see it's not ideal because the vise is in the way, and you can't always get easy access to every part of the workpiece that you need to. It's probably not necessary to bore and ream this hole, and then in this case I'm using a piece of 3/8 inch diameter drill rod. You could probably get by just drilling a 3/8 inch hole and using ordinary cold rolled steel or something. But the advantage of using a tighter tolerance is it centers your cut more evenly around the center diameter of the hole. So at least that's my theory. Alright, well, let's get started, and I'm going to take fairly light cuts just till I see how this goes. Of course, we're using the Y-axis feed here. And I'll come all the way back past the rear end there, and then drop it down maybe a millimeter. Let's try going a little deeper. So you can see it's a pretty slow process. Now we just loosen the vise and we'll rotate it around a little bit more. Take off this next corner here. And now we'll swing it around and work on this corner. I think I'll try 1.5 millimeter depth and see how that goes. Seems okay. Okay, now we'll swing it around again here, take off this corner. Tilt it just a little bit more there. So it's just a matter of repeating that process until it's as round or as smooth as you want it. So you can see with a few minutes work it's shaping up into a pretty good approximation of a circle. So we'll just keep doing that, and eventually we'll take it over on the disc sander and smooth that out. I've shifted the workpiece over to the right hand side of the vise to work on the opposite corner, and I'm taking a 2 millimeter deep cut now. Seems alright. Make sure you lock your Z axis before every cut. To get this final part here done down to the depth that we need, it was necessary to raise the workpiece up on these parallels, and they're just there temporarily until I clamp the vise tight. Now I can remove them. That lets me bring the mill down flush with the top part here, and I can use that as my final depth to finish all the sides. Bring that just about down to touch. And we'll lower it down until it starts to cut. There we go. Okay, so that'll be our reference surface there for the final cuts. And now we just bring the parallels back into place and rotate it around as we did before when it was just in the vise jaws. But with the vise jaws alone, we couldn't get this part of the workpiece up high enough to do the top. So that's why we're doing it this way. Okay, now we can rotate it around a little bit. Make sure it's pressed down against the parallels. You could probably leave the parallels in place, but they're not really doing anything important and they may just vibrate out. That'll save a little time if we can keep them in there. One word of warning, don't ever try to feed the workpiece into the turning end mill unless the workpiece is securely clamped in the vise. If many iterations later we have a reasonably round surface on here, and you can still see some faceting, but I kind of got in the groove and just followed it along and, you know, got into a rhythm working with the hand wheels, and after a while it shaped up pretty nicely. This is where we ended up. You can see it's almost round. You can see the facets if you look. And the interesting thing about this process is that you can, everywhere you see a facet, if you turn it so that that peak is up and take a pass, you can gradually reduce all those little hills so that they become part of the round surface. But I've taken it about as far as I want to go using that method. And we're pretty close now to our diameter for our cap, so we'll take it over to the disc sander and run it around the edge here and see if we can blend some of those peaks together. Well, our end cap has a diameter of about 31.56, we'll call it, and if we slip this under here, it is about 32.14, and some of that of course is the little peaks, so by the time we sand that down it should be very close. Hopefully we won't go too far. Well, we can smooth this surface out first on the belt sander and do a quicker job and probably a better job of blending it. Make sure that the stop here is perpendicular to the belt, but then you can work this back and forth along that flat surface there on the stop and grind that down pretty quickly, and then bring it down to the disc sander for final finishing. So that got most of the high spots off. Now we'll try to, it's hard to get down in these corners here because of the arm extending out. Now we'll try finishing it on the disc sander. One thing to watch out for is you cross the center line of the disc sander and you get over in this portion, it's going to lift the work up, so you have to keep downward pressure on it. And of course keep your fingers away from the wheel. But as long as you keep pressure on it and hold it down to the table, you can work over on this side and get in close to this corner here. Alright, well I'm not 100% happy with that, but it's pretty good for now. We can do some more finishing on that with a hand file, or I'll show you another technique a little later that will clean that up and hopefully put a nice final finish on it.